Let's take a look at negative exponents. So negative exponents, what I like to think of with these is it's just telling you how to move. It's telling you movement from numerator to denominator or denominator to numerator. Basically, you switch location depending on where the value starts. So say we start in the numerator. So this first case here where we have x to the negative n, which if it helps to visualize, you can think of this x to the negative n over 1. So we're starting in the numerator there. And to evaluate with the negative exponents, what we have to do is change it to positive, because we can calculate positive exponents without a calculator. You can understand them better. I mean, with a calculator, we can just plug it in and find it, but in terms of interpretation, we want to end up with positive exponents. In fact, whenever we say like simplify an expression, it isn't simplified with negative exponents still in there. You always have to switch it so that it's all positive in the end. So to do this, if we're starting in the numerator, to make a positive exponent, it moves to the denominator. So we keep the same base, we keep the same number of the exponent, it just changes negative to positive by moving the location to the denominator. Similarly, if we have 1 over x to the negative n, so if we're starting in the denominator, to make it positive, and again, you can kind of visualize your fraction here, it would have to move to the numerator. Base stays the same, the numerical part of the exponent stays the same, it just turns positive. So, for example, if we have x to the negative 4, then that's going to equal 1 over x to the positive 4. So it moves to the denominator, and then base stays the same, exponent practically stays the same, it just switches negative to positive. If we have 1 divided by x to the negative 5th power, then it'll move to the numerator, and we'll have our base of x with a positive exponent of 5. So with these negative exponents, sometimes students try to bring in negative numbers or just switching values around, but really it's just telling you to move. You're just moving the value in terms of location, numerator to denominator, and then nothing else changes about it. It's just about making that positive exponent. So let's look at some similar cases here. We kind of talked about before negatives and how they deal with exponents, but let's then throw in negative exponents as well. So the first example here, 4 to the negative 2 power. So what can help is when you're dealing with these negative exponents is think about your fraction. So I have my numerator and denominator, and then what I just need to analyze is what if I have 4 to the negative 2, that's starting in the numerator, so that needs to move to the denominator. So I'm going to keep that base of 4, but then because I've moved to the denominator, instead of an exponent of negative 2, I now have an exponent of positive 2. And then now I don't have anything left over in the numerator, so I'm just going to use a 1. And then simplifying that 4 squared, now I can make that 1 over 16. So comparing to the original form, like if we didn't have that negative, it would just be 4 squared, which is 16. But what the negative does is it just takes that value of 16 and puts it in the denominator. Okay, say we have negative 4 in parentheses being squared. So we have a positive exponent, so we don't need to move numerator to denominator or anything like that. This is just the same thing as negative 4 times negative 4, and it's because we have those parentheses that we're using that entire negative 4. So that's going to simplify to a positive 16. If we have negative 4 squared without the parentheses, then what we want to do is that negative is not being squared. So that's just going to hang out front. So I just kind of copy that down. But what is being squared is positive 4. So we have this negative out front and then 4 squared, which is 4 times 4. So that would give us negative 16. Let's say we have 1 divided by 4 to -2. So, when I see that negative exponent, I'm going to think about my fraction. So I have numerator, denominator. That negative exponent's occurring in the denominator, so what I need to do is move to the numerator. So we're going to have 4 in the numerator, and then because we moved, that exponent of -2 is now +2. And now I don't have anything left over in the denominator, so there's technically a 1 there. So 4 squared divided by 1 is just a +16. All right, this last one here with -4 to the -2 power without parentheses. So first thing we're going to do is that negative is out front. The only thing that's under that exponent of -2 is the 4. So that negative, I'm just going to go ahead and copy that symbol down so that it's pretty much done. And then 4 to the -2, I need to think about my fraction. So 4 is going to move to the denominator, and that makes an exponent of +2, and I just have a 1 left over in the numerator. So this is going to be a -1/16. The key part there is because that negative is not under the exponent, you can just keep writing it out front so it's kind of out of the way while you calculate the numerical part. So those are some cases where mistakes tend to come up just between negatives and negative exponents, just making sure that you treat them kind of differently. Okay, let's look at some examples. So 2x to the -3rd power. So this is product to a power rule. We have pieces multiplying to an exponent. So that exponent of -3 is going to go to each piece here. And again, just for good habit, I'm going to go ahead and use parentheses, like parentheses 2 to the -3rd power, and then x to the -3rd power. Again, those parentheses aren't entirely necessary here, but it's good practice to have. So 2 to the -3 power. So negative exponent, I'm going to create my fraction, and 2 is going to move to the denominator so that it can have a +3 exponent. So 2 to the -3 is the same thing as 1/2 cubed. And then x to the -3, think about my fraction, this is going to move to the denominator, so it's x, and then it gets an exponent of +3, 1. So multiplying the numerators here, 1 times 1 is just 1, over 2 cubed is 8, and then times x cubed. And here's our answer. All right, 1/3 times x to the -4. Now, when we have these negative exponents, think about what it's actually affecting. So that 3 is on its own. This is 3 times x to the -4. So that 3 is going to stay put. It's not moving anywhere. So 3 is going to stay in the denominator. But then x, because that has an exponent that's negative, that's going to move to the numerator so that it can have a positive exponent. So a common mistake here is that the 3 ends up traveling to the numerator as well, but that's not what happens. It's going to stay in the denominator because it doesn't have a negative exponent. Whereas if this was 1/, and then in parentheses, 3x, close parentheses to the -4th power, then everything would move to the numerator. Then we'd have 3x in the numerator in parentheses to the +4th power, which would be 3 to the 4th times x to the 4th, which would be, let's see, 3 to the 4th power. 3 raised to the 4th power is 81. So 81 x to the 4th. So just a comparison of with and without parentheses. Without parentheses, anything multiplying outside just stays where it was. If it's in parentheses, then everything moves together. Let's say we have a fraction all raised to a negative exponent. Now, quotient to a power rule says that exponent will go to the numerator, go to the denominator, and that works great. A little trick I like to use though, is because that negative exponent, Basically tells you what's in the numerator needs to move to the denominator, what's in the denominator needs to move to the numerator. So what you can do when you have a fraction is just to take care of the negative part of the exponent. Like let's say I keep my parentheses, but I want a positive 2 exponent outside. What you can do is just flip the fraction. So 2/3 would become 3/2, and that would take care of the negative part of that exponent. And then you can just simplify with your positive exponent, and it just makes it a little bit easier. So this would be 9/4. All right, last piece here. So we're multiplying some values. I'm going to have that 2 times 5, which is 10. And then I have x to the -7 times x to the 5th. So that's my product rule. So I need to add those exponents together. So I'm going to have x to the -7 plus 5. So this is going to be 10 times x to the -2 power. And sometimes students end here thinking it's completely simplified, but all exponents need to be positive in the simplified form. So I need to move this x to the -2 piece. Again, 10's multiplying on its own, so 10's going to stay put in the numerator, but x is going to move to the denominator so it can have a positive 2 exponent. So that's what we do with our negative exponents. It's just telling you to move between numerator and denominator.